Welcome everybody to Bitcoin Amsterdam 2024, and the Amsterdam interviews are powered by Bitfavo. And we have a special guest here, Jesse de Wit.
Yes,
welcome.
nice to see you.
He is a Lightning developer at Breez, and of course we had him on the show multiple times.
Yeah, good to see you again, Jesse. It's been a while.
Good to be here. Good to see you in live for once. Right?
Yeah.
I was wondering, we have of course a couple of questions, but maybe first, what you try to take out of this conference? Why are you here?
Why am I here? So first of all, I heard that the entire Lightning Labs team is here. So I really like to meet Lightning Labs team. And what I do at these conferences is mostly just talk to people and get to know some more stuff about.
Yeah, of course.
One thing is I want to learn more about ARC and...
Yeah, of course. Yeah, the other layer 2 development. Yeah,
and I have a bunch of questions ready for people to ask when I meet them.
Do you think at the BitDev yesterday they also talked about ARC or
a little bit?
Were you there? Were you present?
Yeah, I was at the BitDev
okay,
yesterday. Cool. They did talk about ARC a little bit, but it was in some context. I forgot the context though.
Okay. Yeah.
Cool.
Very interesting.
And we spoke just before the recording. The topics we want to discuss obviously have to do with your work on the protocol at Breez. We talked about trampoline payments.
Yes.
That's something I looked up your GitHub and I saw all that activity around this function. Could you explain what trampoline payments are and how they enhance the Lightning Network's functionality?
Right, yeah. So Trampoline has been my pet project for the last few weeks at Breez. And let's explain a little bit maybe how pathfinding works on the Lightning Network. Normally you have a Lightning node, and so you are the sender, and you're trying to pay an invoice from a recipient somewhere in the network. And you will have to find a route through the Lightning Network. You can see the Lightning Network as a graph. You have to find a route through the network to your destination. And how that works normally is you would have all the graph data of where nodes are in the network on your local node. And in order to find a route, you will compute a route like on that local graph, and then you will attempt a payment over that route that you computed. When that route fails, you will redo the same trick. You will compute the route again, and you will attempt to send it over that other route.
And it continues to try up until the payment fails, or you find a route. But that takes some time, right?
Yeah. So up until you either find a route, or there are no more routes available, or there's some timeout.
And it needs to find the whole route. So the one who's paying. Their node is going to find through the Gossip network the whole route.
Yeah, and so that's different than like internet packets are routed through the network. Internet packets, you just give the destination basically, and the router sort of find the route for you. And on the Lightning Network, we call that source-based routing. So the sender already computes the route, and that's also due to the privacy in the Lightning Network, because your packets are wrapped in sort of like an onion. A bit like the Tor network is. So the sender already has to know exactly how to reach the destination. And there's a little bit of an issue with that if you use mobile devices, and especially like we have the Breez SDK with Breez, which means you have a Lightning node in the cloud. But you have your signer, so your keys you have locally on your device. And the thing is, when you compute routes or when you're sending payments, you need to sign for a lot of stuff. So your signer needs to be active. So there's a lot of communication going on between your mobile phone and your node in the cloud. And especially every time you have to retry a payment, all this communication happens again. And so this adds a lot of payment time to a payment.
Yeah, not so practical for emerging markets, for example, or places where the internet is.
And also just if you have like gigabit internet, it's still like it could take a long time for payments to settle. Like, you're talking about like 20 seconds or so.
And if you want to compete, for instance, with Apple Pay, which is instant, you need to build something similar, right?
Yeah. So we want to improve that, and one way to do that is trampoline payments, right? And let's get into that. So. The main aspect of trampoline payments is to offload the pathfinding to another node. So basically what you'll do is you'll send a payment to your peer, which is like in the case of Breez SDK, your peer is the trampoline node. And then that node is going to do the pathfinding for you to the destination. But that node has like a signer directly on the same machine as the node itself, and it has a much better view of the network because it's just an always online server. It can find all of the gossip in the network, so it knows where all the nodes are in the channels, and it does a lot of payments, so it has a good view of where liquidity is in the network.
Instead of the nodes that you're personally connected to, for instance. So maybe I have a connection with you, but you're just a hobbyist and you just have your node running at home. But then there's all kinds of stuff that could go wrong, right? It's not online, or the connection isn't that reliable. In this way, connecting to an LSP is way more reliable, right?
Yeah, right. Generally, LSPs are very reliable nodes. And also, if you just have a node and you're not using it for payments very much, sending payments over Lightning is sort of trial and error. You don't know where liquidity is in the network, so you'll have to try a lot of routes. So, and because you don't do a lot of payments, you don't really see like where in the network is a good place to send a route. And because an LSP, if it's also a trampoline node, and it's doing the pathfinding, that means it's sending a lot of payments, and therefore it can find a much better look on the graph than one of these nodes. So, and the difference is with the Breez SDK, because it's now the mobile device only sends like one single payment part to the LSP, and then the LSP can do all those retries and
the LSP knows the destination and is
and it can
do the trial and error.
It can do all the trial and error stuff, and then that one payment part will either succeed or fail. There's only one communication round going on between your mobile device and your node, and that
so it's more efficient.
So it's a lot more efficient. So that's been my pet project for the last few weeks. It's
a lot of work,
fun to build. I have to make a disclaimer: like it's not the trampoline spec that, for example, Asank is using.
I was thinking about that.
This spec is still being finalized. It should probably be finalized in a couple of weeks, because there's now 2 implementations that are compatible with each other. So once that is finalized, I think we'll move towards their spec, but we sort of implement a simplified version.
Because trampoline routes in that spec, I think when I was at Chaincode Labs studying it was some time ago. So there's a lot of discussion going on, and now it's finally there to test. Because last month, Sébastien Teinturier made the first zero-fee Lightning commitment transaction made possible by Bitcoin Core 28 with version 3 transactions and pay-to-anchor. And what are those zero-fee commitment transactions, and why are they significant for the future of Lightning payments? Well, for the user experience, I guess.
Yeah. So in Bitcoin Core 28, there's now the option of doing a pay-to-anchor.
Yeah.
And basically, what that allows you to do is to create a transaction with 0 fees.
Yeah.
And have a child transaction, spending that transaction that can pay for its fees. And right now, like before Bitcoin 28, if you try to do that, your first transaction with 0 fee would just not get relayed through the network. So you would never be able to confirm that unless you pay some miner out of band or some other way. So having the ability to do a 0 fee transaction is very useful for layer 2 networks like the Lightning Network, because a Lightning channel is in fact like a funding transaction on chain. So you have a transaction which is a 2-of-2 multisig.
Yeah.
You have to collaborate to spend that transaction, and then off chain, you're going to create transactions that spend these. But so these off chain transactions need to have a miner fee in them.
Yeah.
Right now, because you would always have to be able to get that transaction at least in a mempool.
Maybe because of a forced close, or maybe because you collaborate to close that channel.
Yeah, exactly. Yeah, especially these forced close transactions are the important part. So if your peer ever goes offline, you want to have a transaction that you would be able to broadcast to the network at all times. And so if there's a sudden spike, for example, in fee rates, there's a few things that happen. First of all, your transaction may not be able to get in a mempool anymore. And another thing is that nodes might start to disagree on what's a good fee rate for this chain fee rate for this channel. And the third thing is maybe that you need to keep a part of your liquidity in your channel as a reserve.
That's right. Yeah, as a reserve
for these chain fees. And that also grows very large.
That's a real inconvenience.
That's a real inconvenience, especially for smaller channels. So okay. So that's sort of the heads up to what did Bastien do, and so he created like a modification to the Lightning protocol to the way these commitment, these off-chain transactions are created, to allow them to have a zero fee, and that means like it doesn't matter anymore what the current chain fee is. So he really decoupled the Lightning protocol from any chain fee protocol, and that's
real groundbreaking solution to.
That's super useful for protocols like the Lightning.
But because how does this exactly improve the efficiency and reliability of channel management within the Lightning network?
Yeah, so one part is definitely the negotiation. So let's start with the liquidity amount that you have to reserve for a channel. So with Breez, for example, we have a Lightning service provider, and the Lightning service provider has channels to users, but these channels are relatively small usually. You can see them like in the 100,000 sat range.
Really small.
And if you have fee rates, like we saw the 500 sat per fee byte,
or even more,
recently, then a super significant part of the channel is going to be reserved for fees. So like
gotta put
50,000 sat or something. Is just reserved for chain fees.
Yeah, that's crazy.
And if you would want to add an HCLC into the channel, and maybe it's a little bit technical, but the thing is that off-chain transaction becomes a little bit larger. So even routing payments, which you think would not affect your chain fees at all, it does, because your transaction got larger, and so it would take more fees. Even though you would have liquidity available, you may not be able to use that liquidity for a payment. So there it was more efficient. And the other part is the negotiation of this chain fee. It has some it's sometimes it's hard to do that. Like if there's a sudden spike in chain fees, then for example on LMD and a Core Lightning, or even like two different Core Lightning nodes, they might start to disagree on what a good fee rate is, and that might even lead to forced closures of your channel. Which we also saw with the recent sudden fee spike. And so you wouldn't need that anymore.
But because we talked about it just now, what impact do you foresee to the Bitcoin network fee market and transaction processing in a broader perspective?
So for one, I don't know like what will happen to the fee market specifically. I guess the fee market is a super dynamic thing.
It is.
But I guess the fee market would get a more of a sharp tail, I think, because if now you have this option for any layer 2 protocol to have zero fee transactions. So that means only at the moment you start broadcasting, then fees will be added. So at that moment you will probably pay a pretty sharp fee, and if everybody starts doing that, I guess the fee
spike
distribution will really spike towards the latest block. Everybody's trying to get into the first block, basically. But for any layer 2 protocol, anything that works with off-chain transactions, they don't have to worry about that chain fee anymore, and that really, for any layer 2 protocol that enables a lot of stuff, because people have been breaking their heads how to do this. I know there's some people who still disagree that these anchors are a good idea, like Peter Todd, for example.
I've read some of his in the mailing list.
And he's more of a fan of you have to sign transactions with many fee rates.
But I think it's good that a discussion exists, and to also have regard the other perspective if it's good idea. But well, we need to try it, of course, and then trial and error, right? That's Lightning.
And for Lightning, definitely. And so these words like decoupling the chain fees from the Lightning protocol,
that's a huge thing.
I think that's a really big step, and everybody is excited about this because
cool. Cool, man. Hey, let's wrap it up. You also told me that Breez released the Lightning SDK for Liquid. Can you maybe elaborate a bit on that to finalize this conversation?
That's right. So basically, there's a new SDK on Liquid, and that's sort of like a nodeless implementation of the Lightning Network. The user would hold funds on Liquid, and you would be able to interact with the Lightning Network through submarine swaps with bolts. Yeah. That's how it works. With Breez, we built software development kits that are super easy for developers to integrate.
These submarine swaps are trustless, right?
Yeah, these submarine swaps are trustless. And so that now provides you an SDK where it's just super easy to build something where users can interact with Lightning. So definitely check that out.
Yeah.
How to find the Breez website. So.
Yeah, cool, man. Well,
absolutely. Thanks again, Jesse, for our talk. Thanks for listening in. And till next time.
See you later.
Until next time.
Thank you, man.
Yeah.